Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so doing really great. So students, in this video we are going to solve the question from the chapter Dual Nature of Radiation and Matter came in a JEE 2025 exam. Important for the NEET also. Okay, so let's go through it. The question is, an electron of mass m with an initial velocity v naught I cap, where v naught greater than 0, enters an electric field given this one. If the initial de Broglie wavelength is lambda naught, the value after time t would be how much here? Okay, so they are asking the value of the de Broglie wavelength after time t. So this question belongs to the dual nature of matter. Like if we talk about electron, proton, they are particle, they will behave as a wave also. So for that there is the de Broglie scientist was there. He has given his formula to calculate the wavelength. That's why the name is called what? De Broglie wavelength. So what is the formula? Formula, very popular formula, lambda equal to h by mv, where mv is the momentum. Okay, so if we talk about here the initial situation, what is the initial wavelength is there? Initial wavelength is what here? Lambda naught. And what is the initial velocity? V naught I cap. Wavelength is the scalar quantity, so I will just take here the magnitude of the momentum. Okay, so again I'm telling you here, always I will use this formula here, h by magnitude of the momentum. Okay, so this is h, what is the mass is m, initial velocity magnitude how much here? V naught I cap, that means magnitude is what? Magnitude is v naught. Okay, so this is the equation 1. Initial wavelength, de Broglie wavelength, h by mv naught. Okay, next one after that, if we talk about to calculate the new de Broglie wavelength, again we have to use the formula. Let's take this is the initial momentum. After that, let's take the momentum changes to some final momentum is there. Okay, and in this situation I am writing here m into v. That time velocity is what? V. Okay, we are going to calculate this velocity v. Now after that here, if we talk about here some electric field is there, so what will happen? Electron will accelerate also, yes or no, because electron is there. So remember that here, if I talk about here the formula, because you can see very well, electric field is constant, acceleration will be also constant, so we can apply here the equation of motion. So you know very well here, I will write here v equal to v naught, vector v equal to vector v naught plus vector a naught into t. V naught is the initial velocity, v is the final velocity, a naught is what? Initial acceleration. Okay, so I can write here, see, v equal to what is the initial velocity? They are giving here v naught I cap. Okay, if we talk about the acceleration, remember the formula? The formula is what? A equal to, basic formula I am writing here, a equal to f by m, like this, vector a equal to vector f by m. And the relation between force and electric field is what here? Charge. Okay, so q into vector E by m. Okay, this is the basic formula I am writing here. So this formula I am going to use here. So what is the initial acceleration? Electron is having which charge? Negative charge. So minus E into, we can write here vector E. Vector E how much here? You can see very well what is given here, minus E naught k cap. Okay, so we can write here, see, E naught, and minus is there now. Okay, minus I will adjust here. Okay, and after that here what is given here? M into t. Again I am telling you, electron is having which charge? Negative charge here, see here, minus E is there. Okay, this thing. So after that what we can write here, kindly see here, vector v equal to, it will become here v naught I cap, minus minus will become anyhow plus. Okay, then we can write here, see, E naught t by m. Okay, and what this will come here? It will become here the k cap here. Can you see very well the calculations? I think so. All the things are okay only. Okay, is it? Now students, as I told you very well, here wavelength means we have to calculate the magnitude. So we are going to calculate the magnitude of this. Okay, so let me write here, as we know very well what it came here, see, as vector v equal to v naught I cap plus E naught by m here t into k cap here, is it? And this is here, put in a bracket. Now if we talk about here the magnitude. Okay, so what is the magnitude here? It is given by mod v, or we can write here just v is equal to, just here, coefficient of I cap square plus coefficient of this k cap square, E naught T by M, and here square, coefficient of I cap square plus coefficient of k cap square, j cap is not there, okay. So this thing we have got here. Hence from equation 2, from equation 2, what equation 2 we have made here, we can see from here, kindly see here. This is my equation 2, na? This I am going to use here, the new wavelength. So what is this? It will come here. We know very well lambda equal to h by mv, okay. So h, what is the value of the m as it is, and it is given here what? V naught square plus E naught T by M whole square here, okay, like this. Now we'll simplify this here, no? Further simplification, can you see here h and here m, no? Square root. I have taken V naught square common, then what this will become here? 1 plus E naught T by M, it will become here whole square, okay, and this one more bracket is there. If you wish, you can write here the big bracket also, no problem, okay. Then after that, what it will become here, students, we can write here hence lambda equal to h by m, no? This V naught square will come outside of the square root, is it? So this will become here mv naught here, no? And then we can write here square root of 1 plus E naught T by mv naught square here, no? Can you see very well, no? And what is h by mv naught? This will become here this h by mv naught. I am talking about here this thing here. So this will become here what here? Lambda naught by square root of 1 plus E naught T by mv naught square here, okay. And this one I have written here from equation 1, is it? So just let me put here in a box, is it? So see here, this one, this thing we have got here, is it? Can you see very well? No? Can you see here, is it? So let's check here which option is correct here. If we talk about here, the correct option is here, option A is the answer, is it? So students, I hope so. This question based upon the de-Broglie wavelength representing the dual nature of the particle is very, very clear to you. Keep studying, keep growing.